Harsh Mishra and I am a graduate student at Clemson University's Automotive Engineering program. I have created a simple adaptation of adaptive front light. Adaptive front lighting systems adjust the illumination from a vehicle's headlamps to compensate for various driving situations. I have presented 4 modes of working. This is the circuit that has been used. The major components used are 1 blue LEDs to simulate the headlights, 2 photoresistors, one for the ambient light sensing, and the other is placed on the front left to sense light from an oncoming vehicle, 3 servo motors to simulate the motion of the headlamps, potentiometer to simulate the steering motion. Now, for the working of the system. The photo sensors need to be calibrated for the maximum and minimum lighting conditions. This calibration has already been done for the system. Being a basic system representation, the code used asks for calibration once every time the system is reset. The code allows 5 seconds for calibration. Ambient light detection. The system switches the headlamps on and off depending on the ambient light. The ambient light is sensed by the photoresistor, which changes resistance according to the amount of light falling, which is recorded by the code. It is assumed that for a certain amount of light the headlamps would be off, and any light amount below that would turn the headlights on to full brightness, enabling good visibility. For demonstration, now that the ambient lights are on, simulating daytime full brightness, the headlamps are off. When the lights are turned off, nighttime, the headlamps will turn on. Oncoming car detection. The headlamps used in vehicles today are very powerful and bright to improve visibility on the road. They also cover a wide angle in the front. On roads without dividers between both directions of traffic flow or without enough distance, the light from oncoming vehicles tend to blind drivers. This system senses lights from oncoming vehicles. If detected, the system would reduce the brightness of the left headlight to a determined value. The brightness set is such that it does not blind the driver of the oncoming vehicle, but at the same time is enough to maintain minimum visibility on the left side. For demonstration, we can simulate an oncoming headlight using a LED and switch. As soon as the sensor on the front left end detects light, it reduces the brightness of the left headlamp. Turn indicators. Whenever a vehicle is intending to make a turn, it will stop at the intersection and turn on the indicator for the intended turn direction. The system recognizes the driver's intent and it turns that side headlight to the intended direction. Only the headlight on the side on which the turn is intended is rotated. The other headlamp still points in the direction of vehicle facing, thus maintain visibility as well as increasing it on the side. The turn indicators are simulated by means of push buttons, and the servo motor rotates the headlamp. This system can also be used when changing lanes when driving on the highway. In a way similar to explained earlier, this system enables better lane changing with greater visibility. Driving along a curved road. When going through a curve, the headlamps are still directed along the vehicle line. This leads to lower visibility along the curve, especially during sharper turns. This makes it difficult for the driver to see the entire road curve and judge the correct driving input. The system reads the steering input given by the driver, which helps the system determine the curvature of the road. In proportion to the steering input, the system rotates the headlamps towards the curve, improving the visibility of the road and aiding the driver. Also, there will be a dead band at the center of the steering position, as this will enable the small maneuvers made by the drivers to be neglected. The potentiometer is used as a steering wheel. As the resistance of the pot varies, the code determines the steering angle and controls the direction of the headlamps accordingly. Thus, this setup explains 4 different ways in which the adaptive headlamps work for different situations. There are also other conditions such as automatic level control depending on vehicle pitch, adapting high and low beams depending on climate conditions such as rain and fog, that have not been covered in the scope of this project. I hope this simple design helps understand the working of adaptive headlamps. Thank you. Have a great day.